Before we begin, take a moment to get comfortable. Let your arms go heavy, your breath slow. And as you listen, feel free to leave a comment sharing what time it is, where you are, and what city or village you're listening from. It's love to know. And if you'd like more quiet stories like this one, don't forget to subscribe so they gently appear when you need them most. Now, let's begin. There are some nights when the sky feels closer than others, when the stars don't just flicker but seem to pulse, not with light, but with memory, as if something behind them remembers being seen. Tonight is one of those nights. Somewhere in a darkened control room, far from crowds, far from cities, far from sleep, a radio telescope waits. It is vast, quiet, impossibly still. Not because it's broken, but because it's listening. This telescope doesn't blink. It doesn't chatter or whirl. It leans into the silence of space and drinks in radio waves like an old scholar thumbing through forgotten books. And on one uneventful evening, as Earth spun gently beneath it, the telescope heard something. Not a roar, not a crash, it's just a pattern, a soft, persistent signal rising from the blackness between stars. It came from a system not terribly far away, at least, not by cosmic standards. A nearby star, quiet and modest, like a candle at the edge of a hallway. Orbiting it, a single exoplanet with a strange glow, and now a new riddle. The signal was brief, but it repeated. Then it faded. Then it came again. Astronomers didn't panic. It didn't rush to declare discovery. Instead, they did what science always does. They questioned the question. Was it a reflection? Was it a rogue frequency from Earth's cluttered sky? Was it simply space playing its usual tricks? A static echo from a dying star? Or the remnants of a long-forgotten collision? They checked again and again, and each time the whisper was there. Not loud, not clear, but persistent, like a footstep you can't quite trace, somewhere out there. 40 light years from where you lie now, a planet may be exhaling, or breathing in, or just existing in a way we've never fully imagined. But before we dream of messages and meanings, we must first understand what it is we're even hearing. You see, space doesn't talk the way we do. It speaks in wavelengths, in photons and neutrinos, in the way light bends and sound never quite arrives. It speaks slowly, painfully, slowly. This signal, if it truly came from a distant world, left that world decades ago, before smartphones, before the internet curled itself around your daily life, before many of us were born. It traveled across the vacuum, skipping through silence and time, only to arrive now as if it had always been meant for this particular moment. But why now? Why here? The astronomers don't ask those questions aloud, They stay close to the data, to the readouts, to the precision of the moment. They know that space is filled with illusions, that not every flicker is a flame, that not every pulse is a heartbeat. Still ... This one feels different. It does not match the background hum of the universe. It does not resemble the solar flares or the grinding metal of old satellites. It is too regular, it's too polite, and so the team logs the coordinates, files the noise into charts. It turns their attention to the planet orbiting the star where the sound seems to come from. A planet not too hot, not too cold. A world balance, just close enough to its sun to hold liquid water, or so the math suggests. It is there, in the soft gold of what astronomers call the habitable zone, that the light begins to whisper more than heat. Spectrographs peel the colors apart, and in those colors are hints, gases that shouldn't be there unless something or someone put them there. Oxygen, yes, but also methane, to the delicate traces of something else, something no volcano could explain. But this chapter is not about gases. It's about the moment you realize that the universe is, for all its silence, may not be empty. It may be filled with watchers, listeners, beings who do not see with eyes, but feel their stars the way you feel wind on your skin. This chapter is about standing on your porch at night, a glass of water in hand, and looking up not for answers, but for company. Somewhere beyond the veil of atmosphere and clouds and ancient starlight, a signal moves, softly, unhurried, a fingerprint pressed gently on the dark. You won't hear it, not directly. It's too subtle, too distant. But the instruments hear, and now you do too. There is something out there. It might be dust, or data, or a deliberate breath, and maybe, just maybe, it's a kind of greeting, a pause in the long silence of the cosmos. Not a call, not a song. It's just a single note, held across space, waiting for someone to notice. You don't need to understand it. You don't need to solve it. Just close your eyes. Let your thoughts drift upward, past the clouds, past the moon, past the magnetic breath of Earth, till you find yourself floating in the stillness where signals are born and the universe still hums with quiet potential. There, in the hush between stars, a signal waits, wrapped in silence, wrapped in time, wrapped in wonder. And maybe, someday, we'll answer. But tonight, you just rest. The message has already arrived. Not all stars are bold. Some flicker without drama. They do not rage or collapse. They do not blaze with the hunger of giants or burn with the wildness of youth. They simply glow, quietly, reliably, as if their purpose is not to shout across space, but to remain constant and small. The star in question here is one of those. It's not bright enough to see with your naked eye. You could stand under a clear sky for hours and never notice it. It hides behind bigger constellations, forgotten in the folds of more famous names. But the astronomers see it. They know its catalog number. They speak of it in coordinates and parsecs. And now they whisper about the planet circling it because something is strange. This planet doesn't have a name, not really, just a designation, a string of letters and numbers, like a barcode carved into space. But some have started calling it the Whisper Planet, because of the signal, because of the glow, because of the idea that maybe, just maybe, it isn't as alone as it appears. The star, too, has begun to feel like more than a dark in the dark. It has become a location, a place with a story, a fixed point on the map of curiosity. So, what do we know about this silent sun? It's a red dwarf, small, cool, and ancient. Not red like fire, but red like embers burning low and long. These stars live for billions upon billions of years. Some will outlast entire galaxies. They do not rage. They persist, and persistence, it turns out, is what you need if you're going to hold on to life. You see, red dwarfs are tricky hosts. On one hand, they offer stability, low energy, slow aging, no sudden collapses. But on the other, they're unpredictable in youth. They spit flares. They tantrum with radiation. They toss storms like dice across their solar systems. Only the oldest ones, the ones that have mellowed with time, become steady enough for life to consider settling nearby. This one is quiet ember 40 light years away. Seems to have reached that age of calm and its planet. It sits just close enough. Not scorched, not frozen. It's tucked neatly into that narrow band scientists call the Goldilocks zone. It's a poetic term, isn't it? Not too hot, not too cold. It's right, just right for liquid water. It's right for clouds and oceans and maybe even seasons. Just right for hope. Telescopes don't see the planet directly, not yet, and too far, too dim, but they can read its passing. Each time it glides in front of its star, the light dips, just a fraction. Snuff. It's like watching someone walk behind a curtain. You can't see their face, but you know they're there. You know their shape, their timing, their rhythm. Astronomers chart every pass, measure the wobble of the star, how it shifts slightly under the planet's gravity. And from that wobble, they guess the planet's mass, its size, even the hints of its atmosphere. And that's where things get interesting. The atmosphere, that's what it seems to bend the starlight in peculiar ways. It filters the light, alters it. And when scientists run those filtered beams through spectrographs, they find surprises. Ozone, methane, water vapor, even hints of carbon dioxide in strange ratios. These are not proof. Not yet. But they're suggestive, because these gases on Earth are shaped by biology. They are made, in part, by life. Not machines, not accidents, but by organisms, breathing, growing, exhaling. Of course, the planet could be volcanic, or weirdly chemical, or home to processes we simply don't understand yet. But something about the combination feels wrong, or rather feels to right, as if the atmosphere isn't random, but curated, maintained, balanced in a way that mimics ecosystems, not explosions. So the planet gets its nickname, the Whisper Planet, and the star, once just a number in a dusty archive, becomes something more, a possible origin, a birthplace, a quiet parent, nursing a secret. From Earth, we keep watching. Observatories in Chile, Hawaii, and even Antarctica take turns listening. Satellites orbiting our world twist their gaze toward that faint red glimmer. And a James Webb Space Telescope, orbiting far from the blue glow of Earth, devotes more time to staring at that little sun and its peculiar shadow. But there's only so much you can see from here. Even light, the fastest thing we know, takes for decades to get there. If we sent a probe now, it might not arrive until your grandchildren are old. And yet, we keep pointing our instruments that way, because maybe, just maybe, this time is different. Maybe this planet isn't just circling. Its star, maybe, is listening, too. Maybe the signal we caught was never meant to be found. Or maybe it was. Maybe it's a test, a beacon, a technological sigh from a civilization that's already gone, or just beginning, or watching us back. You feel it, don't you? That tug at the edge of wonder. That delicate pull in your chest when you realize there could be others. Not humans, not gods, but organisms with thoughts, with questions, with a sense of home and sky and distance. Organisms who might, just like us, wonder if they're alone. You stare up at your ceiling, but your mind drifts higher. You imagine the surface of that planet, not what Hollywood might show you, not flying, cities or crystalline towers. Maybe it's just moss or clouds or strange bacteria dreaming slowly in warm oceans. Maybe nothing has evolved beyond the single cell. Maybe they haven't yet built tools, or maybe they did long ago and moved on. Or maybe, right now, as you lie in your bed, they're also lying still, looking up, wondering, feeling the whisper, because, in the end, that's what this is, a whisper. Quiet note held between stars, a presence you can't quite touch, but that won't go away. It reminds you of how small you are, but not in a way that belittles, in a way that connects. You're part of something vast, something ancient, a cosmos filled with rhythms and signals and questions older than language. And somewhere, the planet spins quietly around a small red star, a star now known not for its brilliance, for what it might be hiding. You don't need answers tonight, only that feeling, the quiet knowing. The shared sky, sleep now. The star is still glowing. The signal is still echoing. And the story, whatever it may be, is still unfolding, folding. It begins with a whisper of warmth, not too close to the star, not so far that ice wins, thin belt around every sun, where light falls just right. This is the habitable zone. The Goldilocks ring, not too hot, not too cold, just, okay, balanced, and, yet, Balance in space is not so simple. It takes more than warmth to make a world feel alive. There are rules written in rock, spoken by oceans, and whispered through winds that never stop. To be habitable is to hold equilibrium, to breathe just enough, but not too much, to keep water liquid, to invite chemistry into conversation, to let light stir the shadows, but not burn them. So what makes a planet more than just a rock? Let's float through the checklist, slowly, gently, as if drifting through a cosmic garden. First, distance. This one's obvious, and it's always where the conversation begins. A planet too close to its star becomes a furnace. Like Mercury, scorched and silent. No air, no memory of oceans. Too far. And the world becomes an icebox, frozen plains. No liquid water. Only cold, waiting, and silence. But in the middle, habitable zone, something beautiful can happen. Starlight kisses the surface. Temperatures hover around that sacred melting point. Not boiling, not freezing. Water may flow, but even that's not enough, because a rock at the right distance is still just a rock, unless it holds an atmosphere. The atmosphere is everything. It's the planet's breath, its blanket, its shield. It keeps warmth from escaping into the void, lets water vapor rise and fall in a quiet cycle. It softens the sun's harshness, lets light arrive in colors, and keeps radiation at bay. Without it, a world is bare, naked to the stars. Like the moon or Mars. And then there's the question of air itself. What's in the mix? Oxygen, nitrogen, carbon dioxide. The balance is delicate. Too much of one, and everything suffocates. Too little of another, and life can't begin. Earth, for example, has just the right blend. But it didn't start that way. For billions of years, our planet held a toxic atmosphere, thick with volcanic gases. No oxygen, just clouds of poison and steam. Then something changed. Tiny organisms began to breathe in a different way. They took in light and carbon dioxide and released oxygen as waste. And over time, that waste transformed the sky. It took eons, but slowly the air we know was built, not by machines or meteors, but by the quiet persistence of single-celled life. So when scientists look to other planets, they study atmospheres like ancient detectives, sniffing the light, looking for clues in the mix, hoping to find a breath that smells like biology. But still, atmosphere alone isn't enough. A habitable planet needs a magnetic field. Why? Because space is not gentle. Stars spit particles. Winds, made of radiation, scream across systems. A magnetic field is a shield, an invisible barrier that deflects cosmic tantrums. It keeps the atmosphere from being stripped away. It holds the breath in. Earth's magnetic field comes from its molten core, a churning heart of liquid metal, spinning with energy. That spin creates protection. It's why our compass works. It's why the auroras dance near the poles. Without it, life would struggle to survive. The skies would slowly leak into space. Mars, you see, lost its field, and its atmosphere, and then its water. Not all at once, but piece by piece. The planet dried. The breath escaped. So now, when astronomers find a rocky planet in the habitable zone, they ask a quieter question. Does it have a heart that still spins? That question is hard to answer, but it matters, because a world can be beautiful, can even have water, but without protection, it may only be briefly alive in water. Ah, yes, water, the holy grail of habitability. It's not just that life needs water, it's that water is the stage. It dissolves chemicals, it carries nutrients, it shapes environments, it flows into cracks, binds to minerals, evaporates, condenses, returns. It is the great collaborator of life. Without it, molecules cannot dance. They cannot fold into proteins, cannot twist into strands, cannot pass whispers of instruction from one cell to another. And yet, water is shy. It hides. It clings to ice. It lurks beneath surfaces. It flows in brief outbursts before vanishing again. So, when a planet shows signs of water, traces in the light, patterns in the surface, changes in temperature, the world listens more carefully, because where there is water, there may be dreams. Let's not forget time. Habitability is not a snapshot. It's a film. A planet might be perfect today, but what about a billion years ago? Or a billion years from now? Stars age, orbits shift, atmospheres leak, magnetic fields flicker, climate spirals. A truly habitable planet must endure, must hold its balance over eons. It must offer the same shelter through extinction and bloom. Earth has done this barely. It has seen snowball states, global fires, mass extinctions. It has gasped and recovered. It has been bruised, but it has not let go. And now, as we look outward, we search not just for snapshots, but for survivors, for worlds that might hold a rhythm, a cycle, a persistence. But perhaps it's the most overlooked quality of a habitable world: silence. Not silence in sound, but in catastrophe. No constant bombardment, no daily tsunamis, no ceaseless quaking or radiation storms. Just enough calm for complexity to arise, for chemistry to become biology, for cells to organize, for time to stretch. You need patience to grow life, and peace. So, habitability is not just a zone. It's a conversation between warmth and water, between air and magnetism, between stillness and time. And sometimes all those pieces fall into place. Not perfectly, not permanently, but long enough for something to breathe, to move, to become the exoplanet we watch now. The whisper planet sits in that conversation. Its orbit is gentle, its light is stable, its chemistry curious. The signs are not proof, but they are soft suggestions, as if the planet is trying to say, I am here, I am ready, I might be home. And so, we listen, because the dream of habitability is not just about science, it's about story. The story of life looking for itself, of biology searching for mirrors, of sentient beings asking the oldest question in the universe: are we alone? Somewhere, perhaps, that question has already been answered by a planet that found its balance, by an atmosphere that chose life, by a drop of water that remembered how to divide, and maybe, just maybe, by eyes looking back. Light in space is rarely still. It travels across the emptiness like memory across time, a beam that remembers where it came from, what it touched, and what it passed through. When light reaches us from another star, from another world, it brings stories wrapped in silence. And if we look closely, we let prisms and sensors and mirrors slow that light into meaning. We can read it, not with our eyes, but with instruments that stretch light, into language. This is where chemistry enters the conversation. For light, when it filters through a planet's atmosphere, doesn't remain whole. It changes. It bends, scatters, fades. It leaves gaps in the rainbow. These gaps, these soft missing pieces, are called absorption lines, and they tell us everything. Each molecule in the atmosphere, be it oxygen, methane, water vapor, carbon dioxide, eats a specific flavor of light, a unique signature, a fingerprint. So when a planet moves in front of its star, and starlight passes through its thin ring of air, the spectrum changes. We look for what's missing. We don't just see the planet, we see what its atmosphere could be whispering. This is how we first suspected water in distant skies. A faint dip in infrared light. Not dramatic, not shouted. Just a subtle absence where presence should have been. Water, after all, is shy. But even shyness leaves a trace. Now imagine methane, a molecule made often by geology, but more frequently, more consistently, by biology. Methane in a stable atmosphere vanishes quickly. It gets broken apart by sunlight, dispersed. So if you keep finding methane over and over again, year after year, it suggests something is replenishing it. Something is breathing it out. Volcanoes. Maybe. But volcanoes leave other hints. Sulfur ash. Dust. This planet we study now, the Whisper Planet, shows methane in the light, but not alone. It shows oxygen, too. And that's when the eyebrows rise. Because on Earth, oxygen and methane don't like each other. They react. One eats the other. They cannot coexist for long in a closed system unless something or someone is keeping them both stocked. Life does that. It exhales oxygen. It digests and exhales methane. So when we find both in the same atmosphere, we lean forward a little more. It's not a confirmation, but it is a question. And space at its core is built on questions. Still, you must tread carefully, because chemistry doesn't promise life. It only suggests, and many things can mimic many things. On Earth, lightning can make nitrogen compounds. Volcanic vents can make methane. Heaving rocks, when weathered just so, can echo biology's patterns. So the light we read is not a sentence. It's a poem, interpretable, beautiful, but not always clear. This is why we use spectrograph machines that split light like strands of hair, that examine every ripple, every gap, every wobble. And we use filters, many of them, to eliminate the noise of our own atmosphere, to ignore the glint of interstellar dust, to subtract the trembling of mirrors and the hum of electronics. We want only the cleanest, faintest truth. And truth, in this case, is in the colors we cannot see. Ultraviolet, infrared, near infrared, microwaves. These are the tongues of space, and we have only just begun to learn them. The James Webb Space Telescope is our newest translator. It floats far from Earth, cold and dark, wrapped in gold mirrors and quiet purpose. It stares into the distant black and catches light that left its star before our ancestors knew what a star was. And in that light, it looks for winks, for shadows, for strange blinks across a curve. That's how we found the Whisper Planet. A planet not much bigger than Earth, circling a star not unlike our own. A planet whose light carries methane, oxygen, traces of water vapor, and a wobble that doesn't quite belong. That wobble, that soft dance in the planet's orbit, might mean it has a moon, or an ocean, or something moving under clouds. We don't know yet, but we're listening. It's like staring across a canyon at night and seeing a flicker of firelight. You're not sure if someone lit it. Oh, if the wind just caught an ember. But you stare anyway, because even the idea of a presence is enough. The chemistry of light, you see, is gentle. It doesn't scream. It offers possibilities. Maybe these molecules were made by rocks. Maybe by vents. Maybe by a process we don't yet understand. But maybe, just maybe, they were made by something alive, not human, not intelligent, just aware, just growing, breathing, multiplying, dying, trying. That possibility is enough to keep telescopes pointed, to keep data flowing, to keep us whispering to each other through math and code. Did you see that? Because in the chemistry of light, in its soft rainbow scars, you're reminded that we are not just watchers, but participants. We, too, breathe. We, too, change light. We send our own signatures out into the stars. Every second, radio waves, TV broadcasts, telescope signals, the hum of a species dreaming of mirrors. And if someone out there is watching us, they may be reading our light just as we are reading theirs. Maybe they see our oxygen and wonder, could something be breathing there? Maybe they notice the carbon dioxide and say, that looks like industry. Maybe they see our methane and whisper, that smells like cows. Maybe in some quiet lab beneath alien skies. A scientist, not unlike ours, is pointing at Earth and asking the same gentle question. Could it be? Okay. And maybe their answer, like ours, is not yet, not certain, not confirmed, just possible, and possibility is the heartbeat of science. We don't rush to answers. We wander toward them. We let the chemistry speak slowly. We wait for more orbits, more light, more passes in front of the star. Each time, we gather more color, more fingerprints, more hints, and someday, perhaps soon, we'll gather enough to move from poetry to prose, to say not just maybe, but yes. Until then, we stare at spectra. We build better sensors. We question our models. We look for other explanations. And we hope, not in desperation, not in longing, but in gentle curiosity, because even if the whisper planet holds no life, even if its chemistry is just a mimic, just a trick of geology and chance, there are more planets, more stars, more light waiting to be read. And as long as we keep looking, the universe keeps speaking. The sky is not just a ceiling, it is a canvas of chemicals, a tapestry of invisible breath. Above every world, ours and others alike, there drifts a ghostly layer of vapor, gas, and dust. Some of it is born from rocks and oceans, some from heat, some from life to the human eye. It's blank, empty, blue, perhaps, or cloudy. But to a telescope trained in patience, to one tuned not to color, but to chemistry, it sings. And when we speak of biosignatures, we speak of those notes in the sky's long, slow song that shouldn't be there, unless something is alive. It begins, as always, with light. Starlight passes through a planet's atmosphere before reaching us. In doing so, it picks up shadows. These shadows are not dark in the traditional sense, but quiet. They are small dips in the rainbow, missing piece here, a faint absorption there. And each of those missing pieces is a chemical signature. Oxygen, methane, nitrous oxide, water vapor, carbon dioxide, ozone. Individually, they mean something, but together, they whisper possibility. On Earth, for instance, oxygen is not a stable thing. Left alone, it reacts and disappears. But plants keep making more, through photosynthesis, through green leaves and algae blooms. Without life, oxygen would vanish from our air dot. So, if you find oxygen in an alien sky, especially if you find it paired with methanite, is not proof, but it is reason to wonder, because methane and oxygen are enemies. One devours the other. They cannot coexist unless something keeps renewing both. On Earth, that something is life. Thus, in our search for alien breath, we listen for those unlikely companions, for chemistry that feels too tidy, too unstable, too alive. This is the dance of biosignatures, not facts, not declarations, but patterns that make you tilt your head and ask, why? The Whisper Planet Tower, quiet suspect across the stars, has such patterns. Its light, captured across months of orbital passes, reveals not just one molecule, but a curious recipe. Trace methane, with spectral lines sharp and persistent. Molecular oxygen, faint but repeating. A shimmer of ozone, which only forms when oxygen meets sunlight. And, crucially, stable balance. This balance is the part that makes astronomers sit forward. Not just that the chemicals are present, but that they do not change much over time, which implies something is maintaining them. That something could be geology. Maybe the planet has volcanoes churning methane from the crust, or lightning storms that strike oxygen from water vapor. But on Earth, only life keeps the balance, this precisely. So we ask, could the same be true elsewhere? To answer that, we must understand how biosignatures work. Imagine a sealed room. If you introduce methane and oxygen, they will react, burn, even. The oxygen will oxidize the methane, and both will disappear into carbon dioxide and water. The room will settle into a new balance, and the initial ingredients will vanish, unless something inside the room keeps producing them. Now, think of a planet as that. Room-dead atmosphere is a closed system, more or less. Whatever is in it came from the planet itself. And if it remains stable over centuries, it must be constantly renewed. Thus, biosignatures are not static, they are dynamic. They are a kind of planetary metabolism, and when that metabolism echoes Earth's in uncanny ways, we take note. Still, we must be cautious. There have been false positives before. One famous case involved the exoplanet K218b, where hints of water vapors sparked excitement, but follow-up readings were inconclusive. The data was real, but the interpretation was muddied. Another case, the phosphine on Venus debate in 2020. Astronomers believed they had detected phosphine gas on Earth, product of anaerobic life, in the upper clouds of Venus. The news echoed around the world. Could microbial life drift in Venus's acidic skies? But subsequent analyses questioned the measurement. Some suggested it was sulfur dioxide, not phosphine. Others said the signal was buried in noise. Hope receded, but the curiosity remained. That's how science moves, not in leaps, but in breathy steps. One hint, one signal, one peer review at a time. So now, with the Exoplanet, we are more careful. We use multiple instruments, from ground-based telescopes like Keck and VLT, to spaceborne ones like JWST, and soon, the Nancy Grace Roman Telescope. Each telescope sees in slightly different ways. Each contributes another piece to the atmospheric puzzle. And the hope is someday, soon, we will see enough to move from maybe to very likely. But even if we do, there remains a deeper question. What counts as life? Biosignatures are based on what we know on Earth. Life, photosynthesis, respiration, carbon-based cycles. But what if alien life is different? What if it breathes something else, uses silicon, not carbon, thrives in ammonia instead of water? Would we even recognize its breath? That's why biosignature science is not just about detection. It's about expanding our definitions. We now use terms like agnostic biosignatures, markers that don't assume life looks like us. Maybe a repeating chemical cycle, a non-random atmospheric imbalance, a periodic change in reflectivity, like seasonal plant growth or subtle heat patterns that match biological rhythms. We look for anomalies, patterns that nature, left alone, rarely makes. And this brings us back to the sky. The sky of the Exoplanet is still being read. Each orbit gives us a little more. Each transit sharpens the signal, and the light traveling for years, dancing past suns and dust, still carries its secrets. Maybe in its upper atmosphere, there is photochemistry unlike anything we've seen. Maybe there are clouds made of unknown compounds, or maybe there are oceans below, stirring gases into the sky, just as ours once did 3 billion years ago. Maybe we're watching a planet in its Archean stage, Earth, before plants, before animals, a world of microbes and oceans and silence. Not alien intelligence, but alien presence. The kind of presence that doesn't speak, doesn't build, doesn't dream, but lives, breathes, multiplies. That's enough. That's more than enough. Because to find even a microbial world across the stars is to answer a question older than language. Are we alone? And if the answer is no, even in the smallest, simplest way, then everything changes. Not in fear, not in invasion, but in perspective. We would know that life is not a miracle confined to Earth. It is a thread woven into the fabric of the cosmos, in every telescope, every spectrograph, every quiet, blinking observatory becomes not just a tool, but a mirror. We look at them to understand us. We look at alien skies to remember our own beginnings, to remember that Earth, too, once gave off whispers, that Earth, too, once had a sky full of strange signals till someone, somewhere, far away, noticed. It doesn't blink. It doesn't breathe. It doesn't dream. But it waits, suspended above Earth's atmosphere in a cradle of silence and starlight. There floats a mirror, not silver, not glass, but gold, hexagonal, segmented, and so sensitive. It can detect the heat of a bumblebee from the moon. It is not looking at stars, not really. It is reading what light has to say. This is the James Webb Space Telescope, or, as some astronomers call, ETI for the invisible. Most people think telescopes are for seeing stars, but stars are easy, bright, loud, impatient. So true art is seeing what surrounds them, what is lost in the light, drowned by distance, quote, or hidden by time. The James Webb Telescope is not built to see what we can already see. It is built to see infrared, the long, slow light waves that carry heat and memory, light that has stretched itself thin across billions of years. It sees warmth, it sees age, it sees the signatures of things that forgot how to shine. And that's exactly what we need to find the breath of alien worlds, because starlight is a spotlight. It's too bright, but when a planet passes in front of its stars, a tiny blink we can study what the starlight looks like with the planet, and what it looks like without. The difference is the atmosphere. It's like watching someone walk through fog. You can't see them directly, but you can watch how the light bends around them, what it absorbs, what it lets through. This is called transit spectroscopy, one of the most delicate forms of measurement ever attempted by humanity. It's not photography, it's poetry in data. Each photon filtered through an exoplanet's atmosphere carries a story. One photon alone means little, but trillions together form patterns. Patterns of methane, oxygen, water vapor, carbon dioxide, even sulfur, ammonia, hydrogen cyanide. Some of these chemicals exist without life, but some linger only because something is replacing them, again and again, against the logic of chemistry. Webb watches for those stories. It is placed in the L2 Lagrange point, region of space where the gravitational tugs of Earth and Sun balance each other, allowing the telescope to float in quiet synchrony. No low Earth orbit traffic, no atmospheric blur, just stillness, and from that stillness it peers outward, not just to nearby stars, but into the past, because light takes time, and Webb's infrared gaze reaches so far that it is not seeing stars, it is seeing their ghosts, galaxies, as they were 13 billion years ago, the echo of the first hydrogen clouds collapsing into light. But here, closer to home, in the galactic sense, it turns its focus to quieter things, small stars, dim planets, whispers. When it looks at the exoplanet, we now call the whisper planet, it doesn't see continents or clouds, it sees atmospheric fingerprints, and in those fingerprints we find something new, something unsettling, something hopeful. The signature of ozone stronger than expected, methane in a constant state, ever growing, never fading, and a peculiar dip in the infrared curve, unexplained, but consistent. A mystery line, a shadow in the spectrum that doesn't match any known chemical on its own, but may suggest complex organics, not proof, but a puzzle. One worth solving, because every planet is a puzzle, and every solution brings us closer to the question that humanity has whispered for thousands of years. Are we alone? We often imagine that if we found alien life, it would announce itself, ships, signals, structures, but real life doesn't shout, it exudes. It leaks. Its size and the tools we built, like the James Webb Telescope, are built to listen for those sighs. To notice the subtle persistence of PIT. I just know it's going to be a really good day, because I'm going to start out by going to Starbucks. Its size, its end, its size, and the tools make it 1, 1, 1, 1, 1, 1, 1, 1, size, 1, one day, one dies. Imbalance to detect the weight of time in a planet's air. But Webb is not alone. Across the world, from the high deserts of Chile to the dark skies of Hawaii, ground-based observatories watch the stars from a different angle. The extremely large telescope, ELT, in Chile, nearing completion, will have a mirror 39 meters wide, a scale that defies imaginations, larger than a blue whale. Its precision will rival Webb, but from Earth, is tuned for different parts of the light spectrum. And there are more. TESS transiting Exoplanet survey satellite, a wide-field scout looking for dimming stars. It's Plato and ARIEL, European missions, that will follow Webb's footsteps, studying atmospheres and interior compositions. And in planning, the Habitable Worlds Observatory, designed not just to find exoplanets, but to image them directly, not as dots, places. Imagine that, a photograph of another Earth, clouds, seas, weather, maybe even the shimmer of vegetation. That's the dream, and every telescope is a step toward it. But the challenge is not just in the technology. It is in the interpretation, because even perfect data must be red dot, and the sky is full of false friends. Volcanoes that emit methane, chemical reactions that mimic biology, dust that mimics water vapor, solar flares that distort readings. So the scientists wait. They repeat, they analyze, they compare. They ask, is this noise? Or is this nature trying to tell us something? Back on Earth, in control rooms filled with green screens and blinking consoles, teams work through the night. They adjust for stellar wobble. They filter out cosmic rays. They refine models to separate signal from background. And still, the story is slow, because space doesn't rush, and neither does truth. But there is joy in the slowness, in the fact that humanity, for all its chaos, built an eye so gentle, so precise, that they can hear the heartbeat of a planet 50 light years away. And when that eye stares into the void, it is not looking for aliens, it is looking for companionship. Because if we find even microbial life elsewhere, it means Earth is not the universe's exception, it is its expression. It means biology is a theme, it's not a twist. And all across the sky, there may be other planets, sighing, breathing, dreaming quietly, under stars of their own. Webb does not see dreams, but it sees what dreams leave behind: heat, light, patterns, and sometimes the ghost of breath. In the end, the telescope is just a tool, but in its reflection, we see ourselves looking outward. Yes, but also inward, at our longing, at our need to know whether we are the first, or merely one among many. And so the gold eye floats, far from Earth, unblinking, watching, listening, waiting, because somewhere in the dark sky may yet answer. And when it does, we will be ready, not with celebration, perhaps, but with silence. The kind of silence that follows a sacred truth, the kind that reminds you we were never truly alone. We just hadn't learned how to listen. The gas itself is simple, just one carbon for hydrogen, colorless, odorless, light enough to drift toward the stars, but heavy enough, somehow, to weigh on the mind. Methane. Here on Earth, we've learned to live with it, sometimes to fear it. It bubbles from bogs, leaks from buried pipes, and seeps quietly from frozen soils that remember another age. It's natural, it's familiar, but out there on another planet, circling another star, methane begins to feel. It's different, because in the cold, slow theater of space, everything takes time. Nothing lasts without a reason. You see, methane breaks down. It cannot stay forever in an atmosphere without help. The ultraviolet light from a host star tears it apart, rips the fragile bonds between atoms, and scatters them like dust in wind. On Earth, that decay happens in just a few years, So when we see methane lingering, stable and sustained in the skies of a distant exoplanet, it raises a question, not just what put it there, but what is still putting it there now? That's the mystery, because for methane to remain, something must be replacing it. And that something, well, it's either geology or biology. Both are possible. Both are natural. But one feels familiar in a way that echoes deep in the human mind. Let's begin with what we know. On Earth, methane is released from many places. Volcanoes, venting ancient carbon from the molten past. Hydrothermal vents, where the ocean floor breathes gas from stone. Permafrost, thawing under a warming sky. And of course, the digestive tracts of life bacteria in the bellies of cows, termites, and even humans. In truth, the largest source of methane on modern Earth is alive. Tiny microbes, called methanogens, thrive in oxygen-poor environments. Swamps, wetlands, rice paddies, landfills, teas. They eat carbon dioxide and hydrogen and release methane as a waste product. They are some of the simplest, oldest life forms on Earth, and perhaps the most universal, because their needs are few: warmth, carbon, moisture, time. It's not hard to imagine them thriving elsewhere. So, when astronomers see methane in a distant planet's atmosphere, they don't jump to conclusions. They know. It could be a volcano, a deep reservoir, even a strange chemistry we haven't yet imagined. But when they see methane and oxygen together, that's when things become interesting. Because oxygen destroys methane, the two cannot easily coexist. If both are present in stable quantities, something must be replenishing them both on a scale and time scale that suggests ongoing activity. Life, after all, is in balance. It constantly pushes against entropy. It holds together things that should fall apart. The planet in question's dim, slow-turning world in the habitable zone of its quiet star shows a peculiar balance. Infrared spectra reveal persistent methane. And though oxygen is weaker, there are whispers of ozone, a molecule formed when sunlight splits O and recombines it high in the sky. Ozone is fragile. It forms and fades quickly, but when it's stable, it suggests the quiet presence of oxygen. Below together, methane and ozone hint at a chemical dance that defies pure chance. This isn't proof. Not yet, but it's a signal, a clue, that like footprints in snow that don't belong to the wind. And so, the astronomers go deeper. They begin to model the planet, its atmosphere, its pressure, its temperature layers, and cloud formations. They simulate what kind of volcano could produce this methane. They factor in stellar flares, ultraviolet exposure, photochemical decay. They try to make the methane go away to explain it without invoking life, but it remains balanced, consistent, too steady for a fluke. Then comes the harder part. What kind of life could do this on Earth? Methanogens are simple, unicellular, often anaerobic. They do not build or think or leave ruins. They float in mud and darkness, shaping the air without knowing. Could something similar drift through alien oceans? Could it linger in warm ponds beneath icy shells? Or more strangely, could it live in the high clouds of a gas-rich world, feeding on trace gases and sunlight? Life does not have to walk to leave a trace. It only needs to breathe. Back admission. Control, the scientists debate. Some urge caution. They recall Mars and its fleeting methane plumes that faded with seasons. They remember false positives, say biotic processes that mimic biology too well. Others feel a quiet excitement. This planet has been stable for years. The readings repeat. The pattern holds, and when the Webb telescope swings back toward that star, month after month, it confirms the same signal, never stronger, never weaker, like a pulse, a chemical heartbeat now. The press begins to ask questions, but scientists speak slowly. They say, "We have found a biosignature candidate." They say, "We are still ruling out non-biological explanations. They say, it is too early to call this life. In the corridors between briefings, in the quiet of late-night labs, the word if echoes. If this is real, if this is alive, if this changes everything. Meanwhile, philosophers stir. What does it mean to find microbial life? No civilizations, no voices, just cells, just gases, just chemistry that refuses to be alone. Is that enough? Is that the confirmation we've been waiting for? Or will we always want more? A name, a face, a story? But maybe this is the story. Maybe the presence of methane renewed, sustained, defiant as the whisper from the dark. A signal not meant for us, but found by us. And maybe that's the point, because life, in its earliest form, doesn't announce itself with fireworks. It simply persists. It outlives chaos. It survives ice. It floats through darkness and waits. The methane is not a message. It is an echo, and sometimes echoes are all we get. As the night deepens over the observatories, the screens flicker with more data. Light curves, spectral lines, graphs of gas, ratios that shimmer like poetry to those who can read them. And in that soft flicker, one truth grows brighter. There is something out there, holding methane like a lantern in the dark. We do not yet know who or what tends the flame, but the glow remains, and so do we, watching, waiting, breathing deeply beneath skies that might just breathe back. There are skies you've never seen, skies that curve above distant rocks and unfamiliar oceans, skies that shimmer with unfamiliar winds, painted not with the blue you know, but with colors drawn from elements you've only read about: saffron, clouds of sulfur dioxide, turquoise mists of methane and nitrogen, faint green halos where auroras flicker silently against violet dusk. You can't feel the breeze in these atmospheres. You can't stand beneath their weather, but through the lens of a telescope, you can listen to their sighs, not in sound, but in light. Light that has touched strange clouds. It's light that has passed through layers of invisible breath. Light that bends, splits, scatters, and returns across the darkness of space with stories hidden in its spectrum. And those stories are how we begin to know a planet. You see, every atmosphere is a whisper of its world. A soft exhale that tells you, I am warm, I am cold, I am calm, I am full of storms. And sometimes, just sometimes it says, I might be live, but atmospheres lie. Or rather, they tell truths in languages we don't always understand. A thick veil of carbon dioxide could mean greenhouse heat, like Venus, or it could mean a planet choked by volcanic breath, still young and furious. A high concentration of hydrogen might hint at primordial origins and change since the birth of a solar system. Ammonia, maybe the byproduct of chemical weathering, maybe signs of fermentation, maybe something stranger. Each molecule carries potential, but not certainty. And so we watch, and we wait, and we learn to read the weather of worlds we cannot yet reach on Earth. The air is a mixture, 78% nitrogen, 21% oxygen, the rest a trace of other dreams, sargon, carbon dioxide, neon, helium, and more. But oxygen owns the anomaly. It shouldn't stay. It's reactive. It clings to things. It rusts iron, fuels fire, binds to carbon. Left alone, oxygen would vanish from Earth's atmosphere in just a few million years. Yet it stays, because life keeps making it, because plants, cyanobacteria, and algae keep exhaling it as a byproduct of photosynthesis, because Earth is not a closed system, it is alive. So when we find another world with oxygen real, sustained, lingering oxygenate forces, the question, who or what is breathing? But oxygen isn't the only clue. Take ozone, for example, a fragile molecule formed when ultraviolet light splits O and recombines it into a triad. It's our shield, our guardian, okay? Our silent ceiling that blocks out dangerous radiation on exoplanets. Ozone leaves a fingerprint in light-absorbing certain wavelengths, shaping the way starlight bends as it filters through alien skies. It's subtle, it's rare, and it doesn't last long without help. The presence of ozone could mean oxygen, okay? And oxygen could mean life, or it could mean lightning storms, or ultraviolet reactions on barren worlds. The science of alien atmospheres is a science of MAYBES. Then there's methane, still echoing from the previous chapter. Its presence is thrilling. Its persistence is suspicious. Combination with oxygen nearly impossible without ongoing renewal. Alone, methane is mysterious. Paired with oxygen, it becomes provocative. Add nitrous oxide, a gas on Earth, largely produced by soil bacteria. You begin to form a chorus of clues. It's a harmony of imbalance that suggests something more than rocks and heat. You begin to sense a system that isn't settling into chemical silence, but one that is being interrupted, nudged, disturbed, renewed by some ongoing process. Maybe not intelligence, maybe not industry, a metabolism, at the very least, a biosphere, a breath. Now imagine looking at a planet 120 light years away. Your telescope captures the faint glow of starlight passing through its atmosphere during a transita cosmic eclipse. As the planet slips between us and its sun, that light, filtered through alien air, is what astronomers study. They pass it through a spectrograph. They separate the wavelengths. They see dips and rises, sorption lines. Each one a hint of a gas, water vapor, carbon monoxide, sodium, hydrogen, each a trace of a world breathing in its own way. You're not just watching light, you're watching weather. Maybe there are clouds layers of crystalline particles reflecting and refracting light like a dream. Maybe there are storms bands of wind 10,000 kilometers wide, churning endlessly in silence. Maybe there is rain, but not of water. Maybe molten iron falling from coppery clouds. Maybe glass shards driven sideways by 5,000 miles per hour winds. These are the alien size of an atmosphere. Not peaceful, but persistent. Not familiar, but real. Some of the best examples come from gas giants like WASP-121b, where scientists have detected vaporized iron and vanadium oxides in the atmosphere, or HD-189733b, where the sky may rain molten glass sideways. Its color, a deep cobalt blue from silicate particles. These are not worlds for walking. They are not habitable. But they teach us how to listen to air dot, to understand the shape of molecules, the behavior of heat, the ways in which a planet balances its energy. And sometimes we catch a whisper that doesn't belong, like an unexpected DIP in carbon dioxide, or an excess of oxygen, or a stable presence of methane that refuses to fade. And then we wonder again. But there's a kind of humility that comes with studying alien air, because we know our own history. Earth, 3 billion years ago, had no oxygen, It was a haze of methane, nitrogen, ammonia. Life thrived. They're microbial, anaerobic, alien even to us. It wasn't until photosynthetic life arose, first in oceans, then swamps, then everywhere, that oxygen began to rise. And even then, it was a catastrophe for earlier forms of life. The Great Oxygenation Event wiped out countless species. It was, quite literally, the first known mass extinction on Earth. And so we remember, even gases can be violent. Even the atmosphere is a history of trauma. So when we study alien skies, we do it gently. We look for balance, for chemicals out of place, for molecules that shouldn't last but do. We ask, what else is breathing here? Sometimes we find the right pattern, the right rhythm. Oxygen and methane, ozone and carbon dioxide, even water vapor, gently hanging in the air. A planet warm enough to melt, but cool enough to rain. A world not unlike Earth, but not Earth. And in the end, that's what makes these atmospheres so powerful. They're not messages. They're not invitations. They're just truth, held aloft in chemical balance, spoken in wavelengths of light, told by planets that have never seen a human face. They tell us what it means to exist, to drift, to weather the silence of space, to breathe, even if no one hears you. Somewhere out there, right now, a planet is sighing through its atmosphere. The clouds are forming. The wind is stirring dust across alien plains. The gases are shifting, rising, falling. Recombing. Then light from its sun, older than you, faster than thought, is passing through all of it. It will reach us in years. When it does, we will listen and wonder, and breathe a little deeper ourselves, because for all our distance, all our limits, we are, in the end, just one more kind of sky, sighing, dreaming, remembering the stars. Stars. Space is not silent. It hums, it crackles, it whispers across frequencies most ears will never hear. Radiation spills from stars. Particles ping from the sun. Planets echo with magnetospheres, and the universe, at large, breathes in background. Static. The cosmos sings in noise, but every now and then, in the quiet, there is a rhythm that doesn't belong. Not chaos, not randomness, not the usual hiss of entropy, but something that repeats, something that returns, something that stands out like a pattern pressed gently into dust. And when you find that signal, steady, subtle, persistent, you stop, because it might be more. Let's talk about signals. In astronomy, everything begins with light and timing. We observe flickers, we chart pulses, we map interference and decay. Every star has a fingerprint, a brightness curve, spectral signature, a rotational rhythm, so when a telescope detects something odd, a pulse at regular intervals, a brightness dip that defies gravity's explanation, a narrow-band radio signal from deep space, we don't call it life, not yet. We call it an anomaly, because the sky is filled with anomalies, and most of them are perfectly explainable. Spinning neutron stars, also known as pulsars, once confused. Early radio astronomers, they sent out such precise, fast repeating bursts that they were, at first, nicknamed LGM, little green men. But they weren't. They were dead stars, rotating with the inertia of collapsed mass, beaming electromagnetic energy in neat intervals. Not life, just physics. So when scientists today find a signal like the one gently emanating from the exoplanet in question, they approach it with practiced skepticism. First, they confirm the detection. Was it a glitch? Was it interference from Earth? Was it a satellite? A reflection? A quirk of the instruments? They repeat the observation. Different telescopes, okay? Different methods, okay? Different teams, and the signal persists. Then they analyze it. Its wavelength, its shape, its regularity. Does it vary with stellar activity? Does it pulse in sync with the star's magnetic field? No. It holds its own rhythm, separate, stable, something in that system. Not the star, not the space between, but likely the planet is emitting a pattern, and patterns are rare in nature unless something is turning a dial. But what is the signal? It's not a voice. It's not a message. It's not in the way we think of words and grammar and intent. It's more like a nudge. It's a whisper of behavior that doesn't fit the randomness we expect. For example, a consistent dip in light every 13.2 hours, even outside transit. K. Narrow-band radio emission, unlinked to any known astrophysical source. Quasi-spectral echo, not from gas or rock, but from something oscillating in temperature, like a controlled reaction. Nothing so bold as hello, just something that says, I'm still here. The signal in question, the one now being studied by observatories across Earth and in orbit, has a rhythm. Every 7.5 Earth days, it pulses gently in the microwave band. It's faint. Tia. It doesn't carry information, not in any way we can decode, but it returns. It's like someone lighting a lantern in the fog. It's not to call you, but just to let you know they're still awake. It's not loud. It's not bright. It's not demanding. But it's not noise, because noise is irregular, chaotic, random. This SNT. At first, the scientific teams assumed equipment failure. They tested thermal sensors. They reran baselines. They filtered solar interference. Nothing explained it. Then came the theory. Maybe a moon, heating from tidal friction, glowing in infrared every few orbits. A possibility, or perhaps an ancient satellite of the planet. Once ejected, now slowly, spiraling inward, beaming a decaying frequency as it dies. Unlikely, but poetic. Then came a bolder suggestion. Could this be artificial? Could the signal, weak and lazy as it is, be a form of environmental control? Not communication, not broadcast, but function. A planetary process, a mechanism, keeping the atmosphere stable, rebalancing greenhouse gases, or maybe something simpler, a kind of beacon, not for us, but for themselves. And here's the part that keeps some scientists up at night, staring at data, not blinking. If it is artificial, why is it still running? And if it isn't artificial, why is it still perfect? 'Cause even machines degrade. Even natural phenomena change. This one hasn't. For years now. The signal remains gentle, unwavering. Like a metronome beating in a sealed room. Skeptics remind us. Nature surprises us constantly. Planets resonate. Magnetic fields pulse. Plasmas arc and ring in vacuums. Maybe it's a reaction between the star's wind and the planet's ionosphere. Maybe it's a resonant cavity in the exoplanet's crust. It's vibrating like a bell under tidal stress. Maybe it's a perfectly ordinary thing doing a perfectly extraordinary impression of something else. That's the universe for you. But still, the signal doesn't go away. And in science, persistence often means significance. What makes this different? What draws scientists to their scopes and writers? To their metaphors is not the strength of the signal, it's the shape. It's narrow, it's centered, it doesn't drift across frequencies like natural emissions do. It's precise, not inhumanly so, but deliberately so. Like the difference between a rock slide and a footstep. One is noise, the other suggests a body. And yet, no one is claiming aliens. No one is claiming a civilization, 'cause science doesn't make claims, okay? Gathers evidence. It builds slow towers of maybe layer by layer until the weight of data is enough to suggest a change in how we see the world. This might be that tower's foundation, a small, repeating signal from a planet with methane, with temperature stability, with spectral balance, no sign of technology, no city lights, no radio chatter, just a tap on the wall every 7.5 days, as if to say, still here? And what do we do with that? Not much, yet. We don't send messages back. We don't build probes. We don't panic. Instead, we wait. We collect. We watch the rhythm. And we wonder. Because, even if it turns out to be natural, a fluke, a flare, a geological hiccup, it will still have taught us something. It will have reminded us that not all signals are loud, that not all intelligence wears a face, that not all meaning needs translation. Some things are only meant to be witnessed in a small control room on a quiet hill in the middle of a dark country. A technician resets the receiver. She sips her tea. She glances at the TIME.7. 5 days, right? On time. The screen flickers. Signal is there. The same as always. The same as ever. Not noise. It's not speech. Just presence. And for now, it's enough. It's enough. Hope wears a lab coat. It doesn't rush. It doesn't shout. It carries clipboards instead of banners and speaks in citations. Not certainty. Science is not about belief. It is about weight, the weight of proof, the gravity of patterns held long enough to be called truth. And when the universe whispers a strange new song, the scientist does not dance. She listens, she waits, she checks her instruments again, because behind every spectacular discovery is the quiet shadow of a mistake. You might imagine that discovering life, even the faintest hint of it, would erupt in a storm of headlines. Cheers, champagne. But in truth, it often begins with spreadsheets, peer reviews, and months of not trusting your own eyes. Because science is not driven by wonder alone. It is driven by doubt, the disciplined, elegant kind. Doubt that asks, could I be wrong? Is there another explanation? What would convince me otherwise? In this way, science is not arrogant. It is the most humble way we have of telling the truth. Let's imagine what happens the day a strange light curve is noticed, or a signal is picked up that shouldn't be there, or a spectrum contains gases that don't belong in isolation. What comes next is not proclamation, but replication. Other teams must detect the same thing, using different instruments from different vantage points, with no connection to the original observers. Because if a thing is real, it must be repeatable. It must not depend on one pair of eyes, one set of tools, one eager heart. It must survive scrutiny, not once, but endlessly. Then comes the stripping away. What else could cause this? Could it be a telescope calibration error? An echo from Earth's own atmosphere? Reflection from a satellite? Interference from the sun? It's every possible mundane explanation must be exhausted first. The goal of science is not to prove something exists. It is to prove that it cannot be explained away. Only then, when no better story fits the data, can we whisper, maybe. And even then, just maybe, think of methane, found in an exoplanet's atmosphere on Earth. Methane often comes from life, from microbes, digestion, decay. But in the cosmos, it can also come from volcanic activity, chemical reactions in the crust, or ancient pockets of gas released by temperature changes. So we do not say methane equals life. K, methane equals activity. K, methane equals imbalance. An imbalance sustained over time might suggest something that renews, that breathes, that lives, but it might not. And then there's the role of bias. Scientists are not immune to wonder. They are human, after all. They grew up looking at stars, reading science fiction, dreaming of contact. And so they must guard themselves against their own hunger to believe. That's why papers are not accepted because of excitement. They are accepted because of rigor, because they survived peer review, because they made predictions that could be tested and passed. Even if the discovery is small, even if it merely narrows the mystery, not solves it. Science is not about finishing. It is about refining, sharpening, asking again. Remember the story of arsenic life? In 2010, a team of researchers claimed to have found a microbe in California's Mono Lake that could substitute arsenic for phosphorus, an element long considered essential for life. The media exploded. Life as we don't know it. Alien. Biochemistry on Earth. But the scientific community responded differently. They asked for data. They ran tests. They tried to replicate the results, and they couldn't. The claim unraveled not because the team was fraudulent, but because the science wasn't strong enough. The evidence didn't hold. This wasn't a failure. It was the system working. Hope had been dressed in a lab coat, but doubt had the final say. Now, imagine how carefully scientists approach a possible signal from another world. Even more caution, even more scrutiny, because the stakes are high, not just scientifically, but emotionally, culturally, philosophically. If we declare too soon, we risk crying wolf. We damage trust. We blur the line between curiosity and fantasy. So we wait. We gather more light, more spectra, more readings, We build a case, not a headline. And if, someday, that case becomes undeniable, if no natural explanation remains, if every test points to life and the data sings in harmony, then we'll tell the world, but gently, and with the full weight of caution wrapped around every word. In this way, science is the opposite of belief. Belief says, I'm sure. Science says, I'm convinced by the evidence. But now, belief clings. Science lets go when better data comes. Belief is final. Science is open, and that's why it works. That's why it got us antibiotics and space travel and the ability to peer 200 light years away and say, that planet is warm, that atmosphere is complex, and something there is strange, divine, not alien, just strange enough to deserve our attention. This humility is not weakness, it is strength, because to admit uncertainty is to make room for the truth. And the truth, as the cosmos shows us, is rarely simple, rarely immediate, rarely loud. More often, it arrives in whispers, in slow shifts of probability, in graphs and error bars. In nights of silence, followed by a single point of light that doesn't behave as expected. The caution of science is a kind of reverence, a way of saying, I do not own this mystery, but I will listen to it with care. So, where are we now in the story of the signal? Still in the in-between, not proven, not dismissed, just observed, repeated, studied by teams who know that careers are built not on boldness, but on accuracy. They run models. They share raw data. They challenge each other in journals and conferences. And all the while, signal continues every 7.5 days, steady as a heartbeat, not demanding attention, existing, waiting for the moment when the numbers become too heavy to ignore. And even then, the words will come slowly, because science speaks like a tide, not a wave. You might not get a moment, no announcement, no bright red alert across the sky, just a paper, a paragraph. It's a new entry in a database that says, the probability of this being abiotic has dropped below 1%. And in that quiet sentence, everything will change. Not because the universe became louder, but because we finally learned how to listen better. So, sleep now, with the knowledge that somewhere out there, through alien clouds and starlight, a rhythm continues. Not noise, not music, just a beat, measured, watched, respected. Science is still listening, and when it's ready to speak, it will do so with the careful voice of those who know how rare it is for the cosmos to blink back. Blink back. Not every signal is what it seems. Some are gentle misdirections, cosmic tricks of light, timing, and chemistry. They arrive dressed as something unfamiliar, something urgent, something alive. But when you look closer, you find no breath, no pulse, just coincidence. Space is full of friendly deceits, not meant to harm, not meant to fool, but quietly, patiently, they pretend. You see, the universe is clever. It doesn't need intention to create illusion. It doesn't need life to mimic it. Volcanoes can release methane. Lightning can form amino acids. Solar winds can shape magnetic fields that resemble radio transmissions. Nature, in all her chaos, sometimes builds things that look like they were designed. And sometimes, what you thought was a signal turns out to be a shadow. Let's return to the exoplanet, the one whose atmosphere flutters with possibility, the one that hums softly every 7.5 days. It seems to breathe. It seems to glow with gases that, on Earth, are signs of life. Oxygen, methane, even hints of water vapor. But science knows better than to trust appearances, because all of those signs, every one, can come from non-living things. They are called false positives, and they are not failures. They are the universe's way of saying, look again. Start with methane. On Earth, methane is often made by microbes, tiny organisms digesting, breathing, existing beneath soil and sea. So, When we see methane on another world, our hearts flutter. But methane can also come from rocks. Yes, rocks. Specifically, reaction between water and iron-rich minerals in a process called serpent in Izida. It's not a word that makes headlines, but it makes gas that can fill an atmosphere without a single heartbeat. Just heat, pressure, time. Then there's oxygen. On Earth, oxygen is the result of life. Plants, algae, photosynthesis, a process that turns sunlight into breath. So surely, an oxygen-rich planet must be alive. Not always. Sometimes, ultraviolet light from a nearby star can break water vapor into hydrogen and oxygen. The hydrogen escapes into space. The oxygen lingers. No plants, no forest, just chemistry. The oxygen doesn't mean life. It means the possibility has not yet been ruled out. Even water can mislead. Vapor in the air. Frozen lakes, seasonal flows on distant planets. But water is not exclusive to living worlds. It forms in nebulae, on icy moons, between dust particles light years away. And it can exist for billions of years without ever hosting a single living cell. Water is a tool, it's not a guarantee. It's like seeing a spoon and hoping for a meal. In 2015, astronomers studied a distant star, KIC 8,462,852, later nicknamed Tabby Star. Its brightness would dim unpredictably, times by more than 20%. At first, no one knew why. Dust, comet, something passing in front. The patterns were strange, too strange. Some even whispered about alien. Megastructures, massive artificial panels, blocking the light to harvest energy. The idea was not serious, but it stirred the imagination. Headlines followed, speculation swirled, but over time, with more data, the mystery faded. The culprit, likely dust, natural, irregular clouds of fine material orbiting the star. No civilizations, no intent, just particles behaving badly. A friendly deceit. In 1977, another signal was heard. A brief radio burst, just 72 seconds long, detected by a telescope in Ohio. It was narrowband, unusual, unlike typical space noise. A volunteer astronomer circled it on the datasheet and wrote one word beside it. Wow. The wow signal, still unexplained. Never repeated. For decades, it was a beacon of wonder. Evidence, perhaps, of an intelligent transmission. But over time, new theories emerged. Maybe it was a comet, or a rare Earth-based interference. We may never know. But it remains a reminder. Signals are easy to find. Meaning is harder. This is why the caution persists, because for every exciting signal, there are 1,000 misreadings. A reflection from a satellite, a software error, passing bit of space junk that flickers like a thought and vanishes before it can be confirmed. Scientists catalog these moments. They write them down. They build models to weed out the illusions before they bloom. Because if you don't control for false positives, you'll see life in every cloud, every flicker, every echo dot, and in doing so, you'll miss the real signal when it finally comes. Even here on Earth, life is easily mistaken. Viruses straddle the line between living and non-living. Fungi defy classification. Deep-sea microbes survive in boiling vents without light, without oxygen. The rules of life, the checkboxes we use, are built from our experience. But what if life elsewhere is not built like us? What if it breathes metals? What if it sleeps for millennia? What if it never evolves consciousness, only pattern? Would we even recognize it? Or would we dismiss it as noise? This is the scientist's burden, to remain curious without being credulous, to stay open without falling in, to hold wonder in one hand and reason in the other, and let them balance. False positives are not disappointments. They are necessary steps. They refine the tools. They sharpen the questions. They prepare us for the moment when the evidence is real and must be believed. You can think of science like walking a rope stretched across a canyon. On one side, dream, on the other, delusion, and in the middle, data. Each step forward must be tested. Each signal must be verified. Each hope must be weighed against the possibility that it is only a friendly deceit. Back to the signal, the one from the exoplanet, hundreds of trillions of miles away. It still hums, still repeats, still offers just enough intrigue to keep the dishes spinning. But no one is leaping to conclusions. They are collecting more data. They are pointing new instruments. They are watching to see if the gases in the atmosphere shift, if the rhythm changes. Because life, if it's there, won't hide forever. It will exhale. It will glow. It will continue. And the universe, as always, will try to mimic it. For now, we remain suspended in wonder, in question, in the stillness between noise and signal. And as scientists trace the contours of what might be life, they remain humble before the many ways the cosmos can pretend. Because it's not enough to hear something. You must hear it twice, then 3 times, then many times until the illusion falls away and what's left is real. The signal persists. It's not louder, not clearer, but steady. A breath drawn in silence across the void. Some call it natural. Others wonder, could this rhythm have intent? Could it be shaped, crafted, meant? This is the quiet door into one of the most delicate questions humans have ever asked. What does it mean for something, not someone? Is something to be intelligently designed? Okay. And how, in a universe ruled by gravity, chaos, and chemistry, can you ever tell the difference? Begin not with answers, but with the absence of them. When a pattern repeats in space, we don't leap to conclusion. We lean into caution, because the cosmos is full of patterns that emerge from dust and spin and nothing more. Spiral galaxies, symmetrical snowflakes, planetary rings that appear drawn with compass and care. But none of these are designed. They are consequences, beautiful ones, but not decisions. And yet, when a pulse comes at regular intervals, when a rhythm appears, too measured, too persistent, a question flickers. In the 1960s, radio astronomers heard a steady, precise beat. Once every 1.337 seconds, a signal flashed, again and again. They called it LGM1, Little Green Men. They didn't believe it was aliens, not truly, but it was too regular, too perfect, too unlike anything else they detected, until they realized it was a pulsar, a rapidly spinning neutron star, an object the size of a city with the mass of a sun. Its beams swept across Earth like a cosmic lighthouse, perfectly timed, perfectly natural, not intelligent, just precise. So what then would make a signal intelligent? Scientists look for modulation, variations within the signal that carry meaning, not just repetition, but intentional complexity. Imagine someone tapping their finger. Tap, tap, tap. That's a pattern. But now imagine they tap out. Tap, tap, pause, tap, tap, dash, tap, dash, tap, tap, dash, tap, dash, tap, dash, tap, dash, tap, dash, tap, tap. Structure. And if the structure maps to a code, a language, a mathematical sequence, a prime number pattern, then the question deepens. Because nature doesn't send prime numbers. Nature doesn't send Morse code. People do, or something that thinks. The search for extraterrestrial intelligence, says ETI, spends years listening for this kind of complexity, not in sound, but in radio waves, light pulses, and recently, optical lasers. They're not listening for voices. They're listening for fingerprints of thought, signs that someone once tried to say something, even if that someone is not like us. Even if their message is long gone, still drifting like a message in a bottle through space. But the universe doesn't make it easy. Natural phenomena can appear intelligent. Intelligent messages can appear natural. A laser pulse could be from a pulsar. A data stream could be cosmic rays, a flicker in starlight might just be dust, and in our eagerness to understand, we sometimes see design where there is only coincidence. Our brains evolve to find patterns, faces in clouds, voices in noise, meaning in randomness. This makes us good scientists and sometimes gullible dreamers. Still, we search, because even if 999 signals are illusions, the thousandth might not be. So when a rhythm repeats, when a signal shifts its pitch in ways that resemble speech or mathematical structure, we pay attention and we begin to ask questions like, does it repeat at intervals that reflect universal constants, like the hydrogen line, 1.42 gigahertz? Does it encode information in binary? 1 south and 0 south are universal 11 to beings that don't know our language. Does it correct itself, indicating it understands error? Does it change when we send something? Back so far, we've had no conversations, no answers to our hellos, but we're still learning how to listen. It's how to build ears big enough to hear across stars, how to reduce the noise of our own planet so we can notice the whisper beyond it. And there's one more layer. What if the message isn't meant for us? What if it's between others? All from a civilization that died before Earth formed, or sent in a form of physics we don't yet understand. Light, gravity, neutrinos, quantum entanglement. Communication might be happening on a frequency we can't even perceive. And still, we come back to intent to design. If life out there is intelligent, we ask, would they want to be found? Would they try to reach out? Would they speak in light or remain silent out of caution? Because if we've learned anything from our own history, it's that contact can be dangerous. When civilizations meet across oceans, across deserts, across time, the results are rarely peaceful. Why would space be any different? Yet hope remains, because to find another mind in the vast dark, one not born from Earth, not shaped by our history, would be the greatest discovery in human history. It would change theology, philosophy, politics, purpose. Suddenly, we would not be alone, not just biologically, but intellectually. And that idea, however distant, has kept us building better telescopes, launching new probes, designing quiet, patient instruments that listen through the noise. Back to the signal. It's not clear yet. It's no modulation, no obvious pattern, but it's consistent. Some of its properties don't fit known explanations. Its atmospheric data, still inconclusive, suggests oxygen and methane existing side by side, unstable unless something replenishes them, something active or alive. And so, the question of intelligent design remains open. Not every signal needs to be a message. Not every flicker is a wave. But if we stop asking, we might miss the one that is. That quiet flicker at the edge of a distant star. That might say, we're here, or once were, or will be, and that's enough to keep the dishes pointed skyward. To keep our servers storing silence. To keep our ears and our hearts open. When a signal rises, subtle, curious, uncertain, science does not cheer. It leans in, it whispers, it doubts, and then quietly the competition begins. Not the kind with medals or headlines, not the loud race of breaking news, but the slow, serious kind, one observatory passing notes to another. One researcher watching someone else's data like a cloudy mirror, because no discovery, not even the faint breath of alien life, can stand on a single telescope's shoulders. It begins with replication. A second observatory turns its gaze toward the star. Then a third, then another in the southern hemisphere to balance the view, each with its own equipment, its own atmosphere, its own margin of error, each hoping to see the same thing, or to see nothing at all, because science welcomes disagreement. A false positive loves to be alone, but a real signal, it persists, even through different eyes, different skies, different doubts. In the research world, the phrase, is independent verification. It means that even if you trust your own instruments, you wait until someone else with a different telescope, different software, different hands, sees what you see. And if they don't, then maybe the universe was just teasing, a cosmic coincidence, a bit of radiation, a glitch. But if they do, then the rhythm deepens. The whisper becomes a hum, and the competition grows quieter, more respectful, more focused behind the scenes. Teams begin comparing notes, measurements, wavelengths, signal to noise, ratios. A code of calm forms between them. Did your spectrometer register the same dip at 758 nanometers? Was the oxygen signature consistent across polarizations? Can we rule out solar contamination from background flare? The language is technical, detached, but beneath it all is all. Because if this holds, if this light truly carries the trace of breathing, then something out there shares our cosmic habit. It exchanges, consumes, produces, exists. But verification is not always agreement. Sometimes one telescope sees the signal clearly, another sees noise. That's when the questions deepen. Were the viewing conditions identical? Was the calibration current? Did local weather interfere? A thunderstorm in Chile might blur a truth discovered in Arizona. Even space telescopes immune. Two clouds face their own challenges, from sensor degradation to solar radiation to simple human error in analysis. No one rushes to announce life. The history of astronomy is littered with mistakes. In 1967, astronomers detected a signal so regular, so precise, they labeled it LGM, Little Green Men. It wasn't aliens, it was the first known pulsar. In 2015, a blip in star brightness caused headlines. Some suggested an alien megastructure. It was probably dust, and yet the process wasn't foolish. It was rigorous. Each case taught us how to better listen, how to better doubt, how to trust only what survives the long silence of scrutiny. So now, as a new signal drifts across the sky, the quiet competition continues. In Switzerland, a deep sky array recalibrates. In South Africa, engineers fine-tune optics to isolate the atmosphere's signature. In Japan, supercomputer runs simulations. Do natural processes explain this mix of methane and oxygen? In Canada, an archivist checked. Has this star flickered like this before? Has this rhythm been quietly knocking for decades while we weren't listening? Each group works in silence, but they know the others are listening too. It's not rivalry. It's reinforcement, because no one wants to be first. They want to be right. And in the quiet world of exoplanet science, reputation is built not on excitement, but on caution. Better to doubt too long than believe too fast. Sometimes this means the trail goes cold. A signal fades, a cloud returns, a telescope loses funding. A star slips behind the sun for half a year. Science waits, quietly. The data sits, uncertain, unresolved, and still. The instruments hum, because waiting is also part of the method. But not all waiting is passive. Some teams switch tactics. If the atmosphere won't give a straight answer, maybe the planet's surface will. They look for reflected light, a spectrum colored not just by gas, but by what that gas bounces off of. Green light. Maybe chlorophyll, unusual infrared. Maybe heat from something alive, a strange flicker pattern. Maybe cities, structures, movement. Of course, that's science. Fiction for now. But the tools improve every year. What once took a decade of analysis now takes months. Soon, it might take hours. The future of verification is acceleration. And so the quiet competition continues, not just between researchers, but between eras. The telescopes of today compete with the instruments of tomorrow. The James Webb Space Telescope, with its golden eyes, offers more resolution than any eye in history. Soon, it will be joined by the extremely large telescope in Chile. The Roman Space Telescope, the 30-meter telescope in Hawaii. Each one will look deeper, clearer, faster. The signal, if it is still there, won't remain private for long. But here's the strangest part of all. Even if every instrument confirms it, even if the gases line up, the rhythm repeats, the patterns hold even then, we might never know for sure. We might not be able to say with certainty, this is life. Just, this is odd. This shouldn't be here. This smells like biology. Okay? In the world of science, that's enough to ignite a generation of questions. And so, the quiet competition is not about answers. It's about resilience. Can the data survive 1,000 doubts? Can it stay upright as researchers lean on it from every side? Because only then, after months or years or decades, will someone step forward and say, yes, we've seen it. So have they, and they. A consensus formed not by faith, but by method. A discovery not made by one eye, but many, each watching, each doubting, each confirming. This is the beauty of science. Not that it knows, but that it insists on being sure. Even if the truth takes a lifetime, even if the signal fades or deepens or changes again, the work continues quietly together across oceans, borders, time zones, all leading toward the same dim flicker in the sky, all listening for a voice that might be real. Life, such a small word for such an enormous idea. For letters, but they hold every heartbeat, every leaf, every moment of warmth that ever unfolded on a lonely rock in space. We say it easily. We see it everywhere, in birdsong, in bacteria, in breath. But what, exactly, do we mean when we say life? Especially when we're peering light years away, past stars, past time. Two atmospheres will never touch. Do we mean something walking, thinking, building? Or do we mean simply something that continues? On Earth, life wears many forms. It's too many to define by shape or movement or even intelligence. A tree is alive, yet it does not run. A mushroom, alive too, but hidden, quiet. Its thoughts, sif, Indian spoken, and viruses, those strange in-betweeners, aren't even sure if they qualify. They don't breathe. They don't eat, but they reproduce, given a willing cell. Are they life? Are they just replication? Science doesn't always agree, so instead, we define life by functions. Life is a system that consumes energy, responds to its environment, grows, reproduces, and adapts. It moves toward complexity, even if that complexity is quiet. But even this is slippery, because a fire, too, consumes, grows, reacts. It spreads, but it is not alive. And so, the question sharpens, not just what life does, but what it maintains. An inside, separate from the outside. An order, preserved against chaos. Something called homeostasis. That is what separates a living cell from a rock. Not size, not motion, but the delicate preservation of balance inside a membrane, where chemistry becomes consistency, where molecules protect each other, feed each other, prevent the collapse. Imagine a bubble floating in a storm, but inside the bubble, temperature stays steady, acids don't burn, proteins fold, DNA whispers to itself. This, scientists believe, is the minimal unit of life. Not a brain, not awareness, just persistence. So when we say life on another planet, we are not imagining aliens with eyes. We are imagining persistence. Tiny bubbles in alien oceans, microbial films under rocks, organisms that feel no curiosity but resist entropy. They feed, they divide, they survive, and that is enough, because from such simplicity, all complexity may bloom. On Earth, life began in oceans, in warmth, in pressure, in chemistry. A few amino acids found each other, found repetition, found stability, and suddenly, though not suddenly at all, there was replication. Not perfect, persistent. Some bubbles lasted longer, some structures endured. Natural selection began to whisper, and over billions of years, cells became swarms, then colonies, then creatures, not designed, just built, slowly, by survival. So now, when we look to exoplanets, those faraway specks of potential, we ask, can persistence happen there? Does the planet sit in the Goldilocks zone? Not too hot? Not too cold? Does it have liquid water or another stable solvent? Does it have the right ingredients? Carbon, nitrogen, hydrogen, the ancient alphabet of chemistry? Does it have energy? Light from a star, heat from within, chemical gradients to spark reactions. Because with energy and time and complexity, life is no longer impossible. It becomes likely. But even if it arises, will we recognize it? That is the deeper question, because life out there may not resemble anything we know. It may not be carbon-based. It may not breathe oxygen, may not leave fingerprints we're trained to see. It might float in clouds. It might grow on silicon. Okay? It might be so small or so slow that we overlook it entirely. We might be watching it, okay, and not even realize it's watching back. There's a term, life as we don't know it. It's a placeholder for all the possibilities our imaginations can't quite catch. Creatures made of plasma, beings that live in magnetic fields, intelligences too vast to fit inside brains, or too subtle to notice. Could a planet itself be alive, conscious, but metabolic breathing? Volcanoes, exhaling clouds? Could there be life inside stars, on neutron crusts? Cool, on the edge of black holes? We don't know, but we're learning how to ask better. That's why biosignatures are such delicate clues. They aren't life themselves, just as much as life might leave behind. Oxygen in an atmosphere means little unless it shouldn't be there. Methane means something if it exists alongside oxygen, because those two gases destroy each other if they're both present. Something must be replenishing them, and what replenishes methane on Earth? Cows, swamps, bacteria, not stars, not storms, not storms. That's why we lean so close to the latest data, so close to that exoplanet with its strange flickers and suspicious air. It's not proof, but it's close enough to wonder. Maybe the methane is geological. Maybe the oxygen is temporary. But maybe, just maybe, there's something breathing out there. Not with lungs. Not like us, but with persistence, with balance, with hunger and repetition, and slow, determined chemistry against the void. And if we find it, if the data becomes certain, the models agree, and life is declared, it will not be dramatic. Not at first. No contact. No dialogue. No invitation. Just a paper, peer-reviewed, with footnotes and caution. Strong biosignature indications. Observed on Exoplanet HD 40,307 grams. Further observations required. But beneath that modest tone will be a revolution. Because life, even microbial, even mute, will mean we are not a cosmic accident. And if there's life in one place, then the odds rise exponentially. Because the universe is not small. Billions of galaxies, billions of stars in each, trillions of planets. If life happened twice, it probably happened a trillion times. We just haven't found the others yet, and maybe we won't recognize them when we do. But the search teaches us something else, too. It reminds us how rare and beautiful life is here. How fragile, how brief, how miraculous this little experiment on Earth has been. The trees, the music, the minds, even our science is a product of this particular spark. So as we define life out there, we rediscover what it means to be alive down here. Not just to survive, but to wonder, to ask, to reach. Even in sleep, the mind stirs with questions as old as breath. What is life? Are we alone? Are we one small note in a universal song we've only just begun to hear. When you imagine discovering alien life, what do you see? Bright lights above a field, a flying disc lowering onto soil, a curious figure stepping into view, its eyes too large, its skin too smooth, its thoughts unfamiliar, or perhaps a signal, a beep, a pattern, something unmistakably intelligent flickering across a scientist's screen. Perhaps there's celebration, headlines, a global moment, a sudden shift in everything we believe. That's the story we've told ourselves in books, in films, in dreamlike hopes stretched across time. But the real story, if it happens, will arrive differently, slower, quieter, more like a change in weather than an explosion. It won't feel like a movie. It will feel like science. It may begin with a question, or rather, with doubt. A strange spectrum from a telescope light is broken and rearranged, filtered through gases far too familiar to have no cause. Oxygen, methane, something that smells. Of balance, of homeostasis. The data goes to a lab, then to another. A conference call, a preprint on a journal site. A slow rise of curiosity in rooms where no camera rolls. There are no gasps, only silence, only peer review, because the world of discovery is built on the bones of skepticism. First comes the analysis. Was the instrument faulty? Could starlight have warped a reading? Is there a geological cause we haven't accounted for? Someone will say, volcanoes can do that. Another will add, lightning too. Still another. Check the model again. Check the software. Check everything. Because no one wants to be the one who cried alien and was wrong. No one wants a headline that disappears the next day. So the work continues. Long nights of data comparison. More observations. Telescope time requested. Granted. Used. Satellites whisper their readings into Earth's waiting silence. Spectra are gathered from every possible angle. And if the pattern holds, if the gases remained, not fluctuating, not explained away, then something changes. Not a moment, but a tone, a leaning forward. A sentence begins to appear in papers. Biosignature cannot be ruled out. And that is when the world begins to stir, not with panic, not with joy, but with a kind of patient wonder. Because now, the conversation spreads, still among scientists, yes, but also among philosophers, religious scholars, journalists with careful pens. They ask, what do we mean by biosignature? What counts as life? Could it be artificial? Could it be ancient? Long gone, but still breathing in the air. The public hears these whispers. They don't explode, they echo. Because the world is busy. Because alien life, when its molecules on a distant world, feels far away, interesting, yes, but not quite real. Not yet. And still, the discovery deepens. More signs appear, not messages, not machines, but layers of evidence. Isotope ratios that look like digestion. Seasonal shifts in gas that match something. Living, dying, returning. The planet's atmosphere no longer looks random. It looks maintained. It looks curated by something that resists entropy, and that is biology. But even now, no breaking news ticker. No world leaders pausing for comment. Just slow recognition that the universe might not be silent. And yet, no one feels afraid, because it's not dramatic. It's not loud. Okay? It's a puzzle whose pieces are too distant to touch. We are not talking about saucers above our skies. We are talking about microbial persistence on a rock 40 light years away. It will not knock on our door. It may not even know we exist. And so, the world doesn't stop. Children go to school. Coffee shops open. Traffic lights change. But somewhere in the background, something enormous has begun to shift. Imagine this. 2 years after the initial signal, a global team of researchers publishes a consensus paper. The title is careful. Probable Biosignature Detection on Exoplanet XE918F. Inside, tables and footnotes, radiative transfer models, spectral comparisons, but the abstract says it clearly. Taken together, the data suggests a non-geological origin for observed atmospheric compounds. The most likely explanation involves active biological processes. No declaration, no certainty, just science, doing what science does best, letting evidence speak quietly until there is no doubt left to silence it. And so, the world begins to listen. In classrooms, teachers adjust their lesson plans. Astronomy textbooks add a new paragraph. In churches, sermons mention the vastness of creation and the possibility of others. Philosophers write essays about what it means to no longer be alone. And somewhere, a child looks up at the night sky and thinks, maybe they're looking back, even if it's not they as we understand it, even if it's bacteria in alien oceans, even if it's life that has no eyes and no words, it is still life, and that changes everything. But still, no movies are made, not yet, because this isn't a story about contact, it's a story about context, that we are not unique in being alive, that life, this precious thing we cradle, is not a miracle of Earth alone, that the conditions that birthed us, light, warmth, water, time, have done so elsewhere, too, and perhaps many times, perhaps more times than we will ever know. And now you begin to feel the weight of that, not fear, not pride, just humility, the kind that comes from knowing you are part of something much larger than you ever imagined, not just a planet, not just a species, but a universe capable of life in more than one place. Eventually, yes, there may be missions, space. Agencies will propose orbiters, then landers, then sample return systems for distant star systems we cannot yet reach. But not today. Today, we sit with the knowledge that something out there breathes. Maybe not like us. Maybe not even now. But it did, or does. And that is enough to rewrite our relationship with the sky. There will be no press conference with flashing lights. There will be no countdown, no announcement from the moon. Just papers, discussions, lectures, in quiet halls. And in time, cultural shifts so slow you may not even feel it happening. Science fiction becomes science history. Wonder becomes a form of study. The night sky becomes a little more crowded. And in all of this, what changes most is not them, it's us. We are reminded that the universe is not ours, that our place in it is not at the center. And yet, that makes us no smaller, only more aware, more awake to the shared condition of being alive in a cosmos that contains so much we do not yet know. And as you lie still now, the night pressing gently at your window, know this: discovery is rarely loud. It rarely shouts. It arrives like rain, quiet, persistent, changing the world one drop at a time. And somewhere, far beyond your roof, on a planet bathed in alien dawn, something breathes, and that, in its quiet way, has already changed everything. Everything. If the signal is real, if the gases are not just volcanic noise or photochemical tricks, if the patterns persist, what then? What changes? Not the stars, not the distance between us, not the laws of gravity, but something subtle, something slower, like the moment just before sunrise, when the sky doesn't erupt into color, but quietly lets go of the dark dot at first. There's disbelief, even among scientists, even in those who've waited decades to find such a thing. There's hesitation, because a discovery like this life out there, even microbial, even fleeting, it cannot be rushed. It deserves quiet, patience, a breath, held just a little longer. Because if it's real, okay, then we are not alone. And what does that mean? Really? It's not aliens, not civilizations, beaming songs through the void, not greetings or dangers or sudden cosmic neighbors, but something living, something organizing itself against entropy, something metabolizing, breathing in some alien rhythm. Life not from Earth, not descended from the same oceans, not shaped by the same moon, but life nonetheless. The impact won't be loud. Not all at once. There's no button to press, no handshake to give, no mission control countdown. It's not an invasion, not an arrival. It's not even a conversation. It's just confirmation. A page turning in a long book. We've been reading since we stood upright and looked at the sky. Theologists will gather. Their questions will not be simple. If life exists elsewhere, did it too emerge from a divine intention? Or is life a cosmic property, inevitable where conditions are right? Is Earth holy because it is unique, or because it's part of something vast? For some, this news will affirm faith. For others, it will stretch it. But most will find comfort in the possibility that life is not the exception, but the rule. Philosophers will write again. They'll ask whether life has rights, even when it can't speak. If a planet breeds with algae or microbes, do we owe it silence? Respect? Can we still mine it? Land on it? Observe it like a lab rat? Or must we treat it like a cousin, different, but made of the same spark? Even if it's simple, even if it's temporary, even if we never meet, economies won't collapse. No stock markets will crash, but budgets may shift, priorities may lean. Space agencies, once politely tolerated, may find their work central to something greater. The question of are we alone will no longer need asking. The new question becomes, how do we live knowing we are not? Artists will create, not of spacecraft and contact, but of quiet things, what an alien tide might sound like. What it means to be part of a chorus instead of a solo. Songs will hold new metaphors. Poetry will borrow the language of stars. Paintings will try to show what has no face. Children will imagine beings with too many arms, or none at all. Friendly, curious, odd. The stories we tell will change their backdrop from solitude to shared silence. Science will keep moving. It won't slow down. It won't shout. But it will grow bolder. Missions will shift focus. New proposals will be drafted. Should we study from afar? Should we send a probe? Can we protect without interfering? We'll debate ethics of contamination, not just from Earth to there, but from there to us. Sterile gloves will become sacred symbols, because life, even distant and microscopic, is a fragile thing, and it deserves a gentle touch. Politicians will give speeches. Most will be cautious. Some will be hopeful, but the smart ones will listen more than they talk. They'll ask scientists what comes next. They'll ask their people what this means to them, and perhaps, for a moment, our divisions will soften, because wonder is one of the few things that feels the same in every language. Some people won't care, and that's okay. They'll still go to work, still feed their children, still wait in traffic, because life goes on, even in the face of cosmic change. But now, a whisper lives in their world, like a gentle hum behind every day, and someday, that whisper may grow louder. Others will become obsessed. They'll memorize every molecule discovered, every change in the light curve. They'll watch telescopes, track alien skies. They'll write, draw, dream. They'll learn astronomy who never looked up before, not because they need answers, but because they finally believe there are some. And then there are those who will cry, not from fear, not even from joy, but from a quiet grief, because they always believed, and now they're not here to see it. Their grandparents, their mentors, the astronomers who stared into empty skies and saw possibility. This discovery is theirs too. The first breath of an alien world belongs to every person who ever wondered. Over time, the novelty fades, not the wonder, but the urgency. It becomes part of our background, understanding like germs, like black holes, like atoms, known, remarkable, but no longer shocking. That is, till the next signal, until the next light holds another breath. Because now we know where to look. We know what not. Being alone feels like, and it doesn't feel like panic. It feels like relief, like hearing, for the first time, a voice in another room. Distant, unintelligible, but undeniable. And now, you are not just living on Earth. You are part of a living galaxy. So you'll lie down tonight, perhaps thinking about molecules on a world with no name. You close your eyes, and the sky above you feels deeper, not darker, not colder. It's fuller, more alive than you thought. And if you dream softly of quiet planets, of alien winds, of breathing in rhythms we have yet to understand, because life has found a second home. And somewhere, the silence is not silent anymore.